This is the Rehkittz S1600. 4 times brightness. Genuine safety flashlight. Beautiful and bright. High quality wick. Resist compression. Brighter, bigger, bolder. Trustworthy torch. Brightest on the market. Rehkittz S1600.
Hello everybody, today is an exciting day because ElectrArc has got his first fan mail. Shall we have a look? Ooh. There's two things. This looks like a torch. The Rehkittz S1600. Interesting. What else? A Griffin power bank. Oh, and there's two notes. A gift from Leon. Dear ElectrArc, here is an incredible sounding military torch for you to review. Oh. Now I wonder what the power bank's for. Maybe it's just to charge my phone. Let's have a look at this torch then. AA battery. Looks like it can run off an 18650 or a 26650 lithium-ion cell. Rated frequency 200 Hz. Who knows what that means? Rated power 12 watts. Do not shine the flashlight beam directly into anyone's eyes or stare directly into the beam. Material high strength aluminium. Although they've misspelt material. I don't know if you'll be able to see, but they've put Maririal. I'm starting to get the feeling this is a high quality product. Let's crack it open and take a look at what we're working with. There's a tube, so that'll be an adapter for the lithium batteries. So you'll probably find the body of the torch is designed, the biggest thing that'll go in it is the AA adapter, and then the 26650 will need this adapter, and then it looks like this adapter would be for the 18650, because both of those will be smaller than the 3 AA adapter. Oh, it's quite chunky. Wow. Ah, this is brilliant. Thank you very much, Leon. Look at this. It is all aluminium. You can zoom in and out, as is quite common with these torches. But, oh, the lens is enormous on it. Let's get a good measurement of the size of that. So we're looking at 45mm is the width of that lens. Diameter. Crazy. And let's open it up, see if there's anything in it at the moment. I think the AA adapter's probably installed at the moment. Yeah, there we go. Interesting. Now with this type of torch, they usually perform best from the lithium batteries because they can supply the full current and often the higher capacity. So I'm starting to wonder if that's what the power bank is for. Perhaps if this contains an 18650, we could strip it out of here and use it to power the torch. Let's have a look at the power bank next. Griffin, I recognise the name. It says it will charge a smartphone once, which makes sense, 2500 milliamp hours. It's nice and small though. It's also nice and pink. It says it comes with a micro USB charging cable. I can add that to the vast collection. Let's see how stingy they've been. It's not looking good. Oh, not too bad. It's bigger than my ruler. I reckon maybe 30 centimetres. 1 foot cable. Let's see if they tell us. Oh, 30 centimetres. Then Griffin. Oh, I don't know if I want to take this apart. It looks quite nice. I wonder if an 18650 would even fit in here. I wouldn't really use a power bank though, so I guess we might as well strip it open. Let's start by just pulling, seeing if anything will give. Nope, no luck. I'm going to try a little screwdriver now. I don't want to completely break it in case it's not an 18650 power bank. It looks like it probably is, but if it's not, I don't want to just have a broken power supply. Broken power bank, sorry. Hooray! It is an 18650. Perfect. It's a roofer cell. INR 18650. Let's have a look at the datasheet for that. So working from the top down, we can see the first value is for the nominal capacity, 2500 mAh. That's the average capacity of a cell that you could expect if you bought lots. Next is the minimum capacity, which is the capacity guaranteed by the manufacturer. So if you bought 100, they're saying the average would be 2500, but the minimum value would be also 2500 in this case, which is interesting. Then next we've got the internal impedance, which we can just treat as the internal resistance. So from this you can calculate the voltage drop at a given output current. You can also calculate losses in it and estimate how much the battery is going to heat up under heavy discharge. The nominal voltage is 3.7 volts. That's mostly used for energy calculations, so if you times the nominal voltage of 3.7 volts by 2.5 amp hours, that will give you the energy capacity in watt hours. You can sort of think of the nominal voltage as the average voltage throughout a full discharge cycle. Next is the charging current, which is what they expect you to charge at and what they recommend you to charge at, which is 0.5 C. So what that means is it's 0.5 of the capacity. So in this case, 2.5 amp hours would be a charging rate of 1.25 amps is what they recommend, and probably what they mean by that is the maximum. Next is the discharge current, which you can see in the top right in the remarks section. This discharge current is the one that they've measured the capacity at. So basically, the faster you discharge the cell and the harder you work it, the less capacity you're going to get out of it, the less efficiency it will have. So at 0.2 C, you can get your full 2.5 amp hours. But if we look further down at 3.8, you can see that specifies the discharge as 5 C, which would be the maximum continuous discharge, which is 12.5 amps, which is quite a lot. But they're saying if you discharged at 12.5 amps, you're not going to get 2.5 amp hours. Next is the charging voltage, 4.2 volts. So basically that's just the maximum voltage, and the idea is that you stop charging once you reach 4.2 volts. You can see at the nominal voltage section where it says 3.7, on the right the remark is from 4.2 to 2.75. So that's what they're saying is the cell's operating voltage range. 4.2 when it's fully charged, 2.75 when it's fully discharged, which you can see at the bottom, discharge cutoff voltage 2.75 volts. So they're saying you'd also monitor it when you're discharging it and stop when you get to 2.75 volts. Moving over to the right hand page, there's not much else that we're interested in. You can see operating temperature, charge 0 to 45 degrees, discharge minus 20 to 60 degrees. So you'll probably know this if you know much about electric cars, but you can't charge a lot of lithium batteries below freezing. So that's why this has such a restricted temperature range for charging, whereas discharge, it can do that in the cold. That's because of chemistry stuff that I'm afraid I do not understand. Next is something we do care more about, which is the weight. Only 46.2 grams, which is decent for a battery this size, although it is lower capacity than others. Finally, there's the storage temperature, which is very boring because we want to be using our cells, we don't want to be storing them. So I wouldn't really worry about that, but in case you've got lots of batteries, lithium batteries you need to store somewhere, it's quite clear here that for long periods of time they don't like to be anywhere warm, so keep them in a fridge. That's what we do in the Formula Student team. I'm going to cut it free. I think I'll probably measure the voltage first. Oh, 2.5 volts. Maybe I'll charge it first and then strip it out. Let's see if anything happens when I plug it in. Maybe it won't be happy because the cell's so low. I think it's charging. I'm going to take the board out of the enclosure so it's a bit easier to see the LEDs on it. Oh, it's got a tiny little screw. Let's unscrew that. There we go. It's all free. Now I'm going to leave that charging and I will be back in an hour or two to see how it's doing. Right, it's been about an hour and I'm not very happy with the speed this is charging at, so I've unplugged it. The cell's got quite warm, and when I measured the voltage, admittedly while it was charging, it said it was like 4.6 volts or something. So I think I'm going to do the rest of the charging just with a bench power supply, which means it's now time to desolder the cell from its board, so hopefully I'm not going to short it, because we saw on the datasheet it's got quite a lot of energy in it. This board has a date of 18th of December 2017 on it, so that might explain how discharged the cell was. It could have been sitting around for all that time. I've cleaned the cell up a bit, so I used some chemicals on it to get off the glue they'd used to hold it into the power bank enclosure, so it looks a bit nicer now. So it's got these bits of tape on the end to insulate it, and we don't need those anymore, and they'd get in the way of the torch anyway, so let's remove them. So just peel them off. It's just sticky card, and that exposes the end terminals of the cell. For now I'm going to leave the soldered wires on, but once it's charged I'll snip them off so they can go in the torch. I think I have a battery holder for an 18650 that we can use to charge it again in the future. So let's turn the power supply on, and I'll use the first channel because the second channel's set up for testing something. They've used the nice silicon wire, which is always a good sign. Let's go for 4.2 volts, and what did the datasheet say? 0.5C charging current, so that would be 1.2 amps. So let's set the current limit to, I'll set it to 1 amp for now. Turn it on. There we go. That's saying 4.1 volts and it's pushing an amp into it. So I'll leave that charging, and once again I'll be back once it's done. Right, we're at 4.2 volts now, and the charging current's dropped down to 20 milliamps. So let's turn that off, disconnect it. Next I want to remove these wires that are coming off it because we don't need those anymore. I'm going to see if I can pull off the spot welded tabs, but not pull too hard. There's one. This one's not coming off so easily. A bit of it's come off. Oh, this one goes under the film on the battery. Just here, it goes underneath. So I'm not quite sure how to get that one out. There we go. And that, ladies and gentlemen, is how to get a really nice 18650 on Amazon, which I think some people probably thought is impossible. And the power bank this came out of is about £9, so it's not too much more than just buying the cell. Well, it is quite a bit more. I'm just going to measure the voltage again, and then I guess we can try out the torch. 4.196 says the Solartron. Let's see how well it fits in there. Spacer. Oh, it fits quite nicely. 18650 battery tube is embossed into the side of it. It's a shame I don't have a 26, whatever it is. I have one in a different torch, which we're going to compare this torch to, but I don't have a spare one. Right, I guess we'll go ahead then. It is nice having a torch with so much girth. You'll see when I compare it to my other one that I'm not used to this. It does still have a spring contact in the bottom, so in the top it has one of these things, which in my mind are better at high currents than just a normal spring, but maybe that's not true. Right, so I'll put the spacer in first. It is actually directional, this spacer. It's not the same on both ends, so I'm going to try this way around first. And absolutely no indication of polarity. I'll see if the instructions say anything. Check the battery. Do not put the batteries in the wrong direction into the device. Well, that's helpful. Ah, it's got little markings on the side. Positive at the head end. There we go. All screwed in. Here we go. Now I think it's got different brightnesses, so I don't know which this is. Oh. It only has, so it's got 3 modes, which is something they say in the advertising material. So you've got full brightness, then you've got dim, and then you've got strobe. It hasn't got SOS, which is interesting. They usually do. And then I can zoom in and out. Now what I want to do is compare this against my Nitecore that I have here. So you can see there's a very big size difference. This takes the bigger battery, the 26 whatever, and this is 1000 lumens. I trust Nitecore. It also doesn't zoom because it's just something to go wrong. And normally with the zooming torch, you're only going to be at one extremity or the other, whereas this is sort of locked in a nice middle ground. Because it's a proper torch make as well, it's got a nice lens, so you end up with a wide beam and then a sort of tighter, brighter beam inside that. Hopefully that will come across in video later. Anyway, let's compare these. I'm going to turn my main light off. So this is the new torch. And this is the Nitecore. Does look like it could be brighter. New torch. Nitecore. As I say, the beam pattern makes it a bit harder to compare them, but we'll go out when it's dark and hopefully be able to get a better judgment of it. Now I would like to do a full electrical analysis of what's going on inside this torch, but before that I would like to test it outside, so let's do that first and then get back to the cool technical stuff. Right, so here we are outside in the dark. Let's try out the 2 torches. So let's start with the torch I've already got, which is the Nitecore. It's already on. I can adjust the brightness. So this is the dimmest mode, which they claim is 1 lumen. Then you can turn it up to 80 lumens, 300, and finally 1000 lumens, which you can see does a good job at illuminating stuff. Apologies for the wind. Next, let's try the Rehkitt's. I didn't forget the name. Now this has far fewer brightness modes. You've just got a dim mode and a bright mode basically. So I'll try the dim mode first. Right, so this is it on the dim mode. Right now I'm zoomed out and you can see it does a good job at making a wide floodlight, and then you can zoom in and it doesn't really do very much. That's what these zooming torches tend to do, is they're alright when they're zoomed out, but when you zoom in, it's more like cropping the light. You don't really gain much. I think that's because internally, the lens structure is just not really designed for zooming. They've got a lens that works well at a certain focal distance, and then when you zoom in, you're just pushing that lens away, and it doesn't really achieve much. You end up with a lot of light just hitting the inside of the torch, which is black, and just getting absorbed. So that's why I don't really like zooming torches. Right, so we're going to do a side-by-side comparison now. This is the Rehkitt's. We've got it zoomed out and then zoomed in. I'll start with it zoomed out, and now we're going to swap it for the Nitecore. And then we'll swap it back again. And I can zoom in a bit. I'll do full zoom and then compare it against the Nitecore. So you can see the Nitecore is basically the Rehkitt's that's zoomed out and zoomed in at the same time. That's why I'm a big fan of the fixed lens design. Now that we're back inside, I want to take the torch apart as much as possible to evaluate some of the claims they've made, like a dual lens structure and constant current control system. I want to try and lay it all out nicely, so I've got the AA battery holder here, I've got the spacer for the 26650 cell, and now I'm going to speed myself up taking it apart. This is a good time to have a look inside the torch and see how much space internally is wasted if you're using an 18650. Hopefully you can see that somewhat clearly. You can see the adapter inside. It's probably well over the cell's volume again. It's just air. Just looking at the cell in the spacer also shows the spacer's pretty tight against the inside of the torch body, and oh, there's just so much wasted space. I'm going to tell myself it's for cooling purposes. Even though the cooling would probably be worse because the cell's not got any heat dissipation through the body. Although neither would the 26650 because that's also got a plastic sleeve. So as is quite common with these torches, you can unscrew the front cap to reveal the lens. I imagine there's just one lens, not two like they claimed. There's lots of O-ring seals, which is quite nice. So you can see there's an O-ring on this piece, which is the sort of front bezel maybe that screws in, and then you've got another O-ring that O-ring mates onto on the actual torch itself, which is nice. There's the lens out. With a torch this style, with the lens, it's often very difficult to gauge the size of the LED because the LED looks enormous through the lens. Here you can see that's the size of the LED without a lens on, and then if I hold the lens over, it really messes with the perspective, which I guess is the point. Now I think to take it apart further, what I need to do is get in here with some pliers or a screwdriver or something, and basically, if you imagine some long needle nose pliers, put one prong in each of these gaps, just pick two of them that are opposite, and then see if I can rotate it, because I think this is threaded in. So I'm going to try that now. Oh, I've scratched the inside a bit. I've got to try and be a bit more careful, because this is a really nice looking torch. Oh, there we go, something's spinning. Hopefully I'm not going to break anything. There we go. That's the battery housing off. And then I think I can probably just push this out the front. There we go. Oh, it's almost fully disassembled. Now I'm slightly worried that I can't go any further inside, which is a bit sad. So that makes it quite hard to know if they've got this constant current circuitry. Clearly they didn't have a dual lens structure, this is just one lens. Unless they're talking about the lens that's built onto the LED, which maybe they could be. Another claim we can have a look at is that they say it draws 1.5 amps at 4 volts, and somehow they get 10 watts from that. So I presume one of the numbers might be true. Let's have a look with the power supply. Now to connect to this, I'm just treating the spring as positive because if you remember, the positive end of the battery goes in the head of the torch, so that would be what presses up against the spring. And then the negative I'm just going to touch up against this metal. Because, a bit like a car, these torches use the chassis, the shell of the torch, as the negative conductor. To play it safe, I'm going to start at 3.2 volts. Turn it on. Let's touch this. Ah! It's really bright. I'm going to get some sunglasses. Right, let's continue. So I can simulate the button here and I can change the mode so you can see this is full power, then this is low power, and then that's flashing. Full power is all that we care about, of course, and at full power we're drawing 1 amp at 3 volts. Now I guess if it has a constant current driver, increasing the voltage from 3 volts to 4 volts, the current should stay around 1 amp. Although it may increase a bit because right now I imagine the 1 amp is probably limited by the forward voltage, not any circuitry. So we might keep going until we hit 1.5 like they've claimed, and then stick at that. We'll have a go. In case you're interested, so full power, as I say, is 1 amp, then low power is about 200 milliamps, so it's about a fifth of the current. Let's try 4 volts now. There we go, turn the voltage up. Oh, yeah. I thought they might have done this. So, these cheap torches are normally absolutely shit, because basically the internal circuitry probably just puts the LED straight across the cell, and so when you first buy it you're like, wow, this is bright, and they're running the LED at like 3 times its rated current, and then after an hour of on time the LED is just completely frazzled and it barely lights up. But most people don't use torches very much, so no one really notices. They just turn it on, go wow, leave a good review, and then by the time they go back to leave a bad review the listing's probably changed its name. So that's one reason why that Nitecore that I've got costs 5 times as much as this, is because they're actually doing it properly. They will have probably a switching constant current driver circuit, driving the LED with high efficiency, making sure it's not overcurrent. They're probably underrunning the LED, even at full power, because I think when I checked, the torch runs the LED with about 10 watts, and the LED's rated for 12 watts or something like that. Anyway, let's keep turning the voltage up and see. I don't know if you can see the current from there, but it reached the current limit of my power supply at 2 amps, so I guess I'll swap to a different power supply. Right, so this power supply is good for 30 volts at 5 amps, so it should be a bit better for us. It's got analog displays though, which is always a bit scary. I'm going to connect my voltmeter to it actually, just to make sure we're safe. Looks like it mostly agrees. The dial looks like it's about 3.5 volts, and the multimeter says 3.4. It just means I won't get an accurate measurement of the current, but the dial's fairly good actually. I can switch it to the low range and increase the current limit. Now it's got a current limit of 2.5 amps, so as long as we don't reach that, it gives me a lot more resolution in my dial. The problem is, because of the different modes, if you accidentally take the connection off really briefly, then it changes mode because of the way it's changed with the power button. The way they do that is the processor, whatever they've got on it, it'll have probably like a big capacitor on it. So let's say, for simplicity, you've got the battery, then a diode, and then this capacitor. The microcontroller might have a GPIO pin connected to the battery side, and then when you turn it off, the battery side would then say 0 volts, but the capacitor's still charged enough for the processor to keep running. So it would then detect that that's happened, and then when you turn it back on, if you turn it on while the capacitor's still charged, so the microcontroller's still running, then it would say, I haven't had time to turn off properly. That means you pressed it quick. That means I should change mode. So right now it's drawing 1.5 amps. I'll turn the voltage up a bit and see what happens. So now it's at 4 volts and it's drawing 3 amps. The current's quite erratic though, which I think is probably because I've got a bad connection onto this. I'm not really giving it its best shot. But yeah, interestingly, another sign of a bad torch that we've got here is that the brightness is affected a lot by the voltage of the cell. So, I don't know, I'll turn this light off, hopefully you'll be able to see it a bit better. How much the light intensity changes when I go 4 volts here, then down to 3.3, up to 4, down to 3.3. If it had a good, true constant current driver circuit, the light output would stay the same, independent of the cell voltage. Interestingly, I can actually hear things going on inside. I'll put this right next to the microphone and see if you can hear it. So this is on full brightness. This is on lower brightness. I don't know if you can hear, but it's sort of, there's a like high frequency switching sound. And then on flashing. Don't know if you can hear that. It's almost like you can hear a relay in there. Obviously it's not a relay, but yeah, there's definitely something going on. And that sound and the switching sound does make me think that there's some kind of switching going on inside it. If you imagine, there'll be an inductor there probably for the switching. You'll probably find at the highest power, it's just switching it, it's just, the MOSFET's just staying on, and it is just battery straight onto the LED. So then for flashing, the MOSFET would just be going like on, off like that. And if you imagine the amount of current that the inductor's seeing, it's going to be causing some actual mechanical stuff to happen inside the inductor when it's on for that long. So it looks like it's probably on for like 200 milliseconds. So it might be on for 200 milliseconds, and in that time the inductor's like fully saturated, and then you suddenly release it, all that energy's got to go somewhere, and it'll probably go through a diode or something, but just such big transients will end up producing mechanical effects, because if you imagine the inductor stores its energy as a magnetic field, there's going to be something in there, probably the magnetic core of the inductor is going to be influenced by that magnetic field, so when it suddenly gets stronger and weaker, you could find that the core moves a little bit or something like that. You'll sort of know this effect if you've got a delaminated transformer. The humming, instead of just being a gentle it's more brutal because you've got bits of metal banging against each other, so it's like So that's about all for this video, sadly, but I have some very exciting plans for this torch because the head is so large that I could make a custom PCB, and there's a lot of space for it. I basically have all of this volume to play with. I'll probably make a video in the next week or two discussing my plans for this torch, so I've got some quite cool ideas, and maybe we could go through the design process of what I'm thinking of making. The only problem is that it's looking like it would be quite expensive, so I might not be able to actually make it, unfortunately. With regards to that though, I am going to try and make a little PayPal link thing that you can click on if you feel like supporting me. If I come up with something that you think would be cool, then feel free to donate. All of that would go straight into this project. So if someone donated me £100, I'd spend £100 on some really nice LEDs and things. None of it's going... what else would I spend it on? Right, so I'll end it there. Thank you very much for watching, and until next time, goodbye.